Chapter 9, Section 6 is about the quadratic formula and the discriminant. Part 1 is just going to be about the quadratic formula. Part 2 will be about the discriminant. So by the end of this lesson, you should be able to solve the quadratic function by using the quadratic formula and determine the number of solutions of a quadratic function by using that discriminant that we'll tell you about in Part 2. But first part is this actual quadratic formula. It's a big formula, but we'll teach you a way to remember it tomorrow. The formula is x equals, so your x's or your solutions are equal to negative b plus or minus the square root of b squared minus 4 times ac, all divided by 2 times a. Okay, remembering that a goes with the x squared, b goes with the x, and c is the constant. This happens at any time a is not equal to 0. Okay, so of course here they give you an example, and all you're doing is you're plugging things in. Here's your a value, which shows up here and here. Your b value is here and here, and then your c value is right there. And then once we solve it all, you should get 2 answers because you're doing both the positive and the negative. Why on earth would you use something that's this big and crazy? Because it always works, no matter if you can factor or not. If you're not sure, this will always work, and it might even be more faster and more exact than other methods. All right, so using the quadratic formula, here's your first example. If they're giving us this x squared minus 8 equals 2x, remember that the very first thing you have to do is write it in standard form. In case you forgot what standard form is, that means that it all has to equal 0. So it has to be ax squared plus bx plus c equals 0. Okay, so that's why in order to get that, they had to subtract 2x to get it all on one side and have it be equal to 0. Then we'll just plug in what we know. Your a is 1, your b is negative 2, and your c is negative 8. So that's where they're getting all of these numbers. Okay, once they actually do the math underneath the square root symbol, they get 36. Remember here that it's negative 2, which turns it into a positive 2. So we have 2 plus or minus the square root of 36, all divided by 2. Then right there, once I figure out the square root of 36, that's where I'm going to split it. So I'm going to have 2 plus 6 divided by 2 gives us 4. And 2 minus 6 divided by 2 gives us negative 2. So those are your 2 solutions. All right, let's try this first one that they give us down here at the bottom. We don't have a lot of room here, so we might have to, actually, let's just put it on the next page here. So it's x squared minus 4x equals 21. Okay, remember that we have to have it in standard form, so we're going to have to subtract 21 from both sides, giving us x squared minus 4x minus 21 equals 0. Okay, and now I can use that quadratic formula. I'm going to write it over here just so you remember. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, we're just going to leave that off to the side here. All right, remember that this is our a, our b, and our c. So when I plug this in, I will have x equals negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c, all over 2 times a. All right, well, underneath that square root, I have 16, because negative 4 to the second power is 16, minus a negative 80. So 16 plus 80, which gives me 96. So in my next line, I'm going to have square root of 96, plus and minus, and a negative 4 is just 4, all over 2 times 1, which is 2. Okay, now here I'm going to split it, and we're going to do x is equal to 4 plus the square root of 96 divided by 2, and x is equal to 4 minus the square root of 96 divided by 2. Because there's not a perfect square root of 96, I'm going to do this on a calculator, and then at the end I'm just going to round it to the nearest tenth. And the first one is going to give me approximately 6.9. The second one is going to give me approximately negative 2.9. Those are my solutions for this quadratic function. All right, let's try to, this is a good spot that you could maybe pause this and try them on your own if you think you're ready, and then come back and do it with me. Otherwise, you can just hang out here and do it with me from the beginning. Okay, so we're going to start. Again, we have that x equals negative b plus or minus the square root of 2. X equals negative b plus or minus square root b squared, minus 4 times a times c all over 2a. I don't have room to write it on here, so hopefully you have it on a piece of paper next to you or look back in your notes. But remember, here's our a, here's our b, and here's our c. So when I plug these in, I have x is equal to negative b. So we've got 11, a positive 11, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, we're going to start narrowing it down. So we know we have this positive 11, still plus or minus, underneath the square root. 11 squared is 121, minus 4 times negative 3 is negative 12, times 4 makes it negative 48, but it's negative. So we have 121 plus 48 underneath here, all divided by negative 6. So keep going. X equals 11 plus or minus. If I add together 121 and 148, I get 169 divided by negative 6. So now here I can split. 169 is a perfect square root, so I can do that one real easy. We'll have x is equal to 11 plus 13 over negative 6, and x is equal to 11 minus 13 divided by negative 6, which is going to tell me that x is equal to negative 4, and x is equal to a positive 1/3. Two solutions. All right, the second one, I have to get this so that I have a 0, so that it's in standard form. So I'm going to subtract 8, which is going to give me 7x squared minus 2x minus 8 equals 0. Okay, when I use my quadratic formula, I will have x is equal to a negative 2, so positive 2, plus or minus the square root of negative 2 squared minus 4 times a times c all over 2 times a. All right. If I do all the work underneath the exponent or the square root symbol, negative 2 squared is 4. 4 times 7 times negative 8 is negative 224. So we're going to add 4 plus 224, since a minus a negative turns into a plus, and I get the square root of 228, which unfortunately is not perfect, all over 14. So here's where I can split it. X is equal to 2 plus the square root of 228 over 14, and x is equal to 2 minus the square root of 228 all over 14, which tells me that x is approximately 1.22 and x is approximately negative 0.94. Excuse me. Okay, word problem. In the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by the equation y is equal to negative 0.04x squared plus 0.84x plus 2. X is the horizontal distance in meters, so how far forward it goes from the athlete, and y is the height in meters of the ball, how high it goes. How far from the athlete will the ball land? Okay, so since we're looking at this horizontal distance, when they say how far, that means we're trying to solve for x, trying to figure out what those x's are. So just solving this quadratic function. Okay, it's already in standard form if we just have a y in there for 0. So now we're going to plug into our quadratic formula. X equals negative b, which is negative 0.84, plus or minus the square root of 0.84 squared minus 4 times our a times c all over 2 times that negative 0.04. All right, when I do the math underneath the square root symbol, it leads me to a 1.0256. And 2 times negative 0.04 is negative 0.08. Okay, so now I'm going to split it. And I'm going to do x is equal to negative 0.84 plus the square root of 1.0256 all divided by negative 0.08. And that's going to tell me that I get approximately negative 2.16 meters. And the second one, when I split, is going to be x is equal to negative 0.84 minus the square root of 1.0256 all divided by negative 0.08. And with a calculator, that tells me that it's approximately 23.16 meters. Now this one can't have two answers because it can't land two distances away from the shot putter, from the athlete. So we're going to look at the one that makes sense. Because this one has negative meters, that one does not make any sense. You can't be negative meters away from somebody, so this one's not reasonable. That means our final answer, or our solution, is that it landed approximately 23.16 meters away from that athlete. All right, last one for today, and I'm going to have you try this one on your own and then come back and just check your work with mine. Jacob tosses a baseball across the playground. The arc of the ball can be measured by the equation shown below, where x is the horizontal distance and y is the height. How far from Jacob does the ball land? So just like yesterday, you're using this as your a term, this is your b term, and this is your c. Plug it into that quadratic function and choose which of the two solutions is reasonable and makes the most sense. Okay, so here's a place that you should pause it, work this problem out on your own, and then come back and follow along and see if your work matches mine. All right, because I can't be negative distance away from something, this one is our unreasonable, and 19.17 units, since it doesn't say if this is feet or not, but I'm assuming feet, 19.17 units is our solution for this word problem. Okay, remember that this is a two-part lesson, but the full lesson is on page 571, numbers 8 through 22 evens, 23 through 40, and then the lesson.